Hello everyone, Dr. Alex Vasquez here with video number 2 in this series on cardio nutrition. Today I'm going to talk about structural and functional importance of urinary alkalinization against mild metabolic acidosis. Today I'm going to start by reviewing the following articles, 3 of which are new, and the 4th is one that I introduced in cardio nutrition number 1, and I'm going to discuss that in more detail today. First, of course, we want to start by defining what it is we're talking about. And the topic today, as I've already mentioned, is metabolic acidosis. And here I'm going to talk about subtypes per cause and severity. These divisions and categorizations are my own ways of thinking about this situation, but I still think that it's clinically relevant. Even though these terms and nomenclature are not necessarily official, we just look at things here from kind of a common sense perspective. So when we talk about metabolic acidosis, we all, of course, appreciate that in some cases metabolic acidosis can be very severe. The context here is a very complex condition and major deviation from normal physiology, which is always resultant from a serious cause, and that cause itself must be treated directly while other resuscitative interventions are applied. Severe metabolic acidosis is characterized by decreased blood bicarbonate levels with blood acidemia, also reduced carbon dioxide secondary to the compensatory hyperventilation. This is typically divided into increased or normal anion gap acidosis. Typical causes include diabetic ketoacidosis, lactic, alcoholic, and poisoning acidosis, uremia, and renal tubular acidosis. Severe metabolic acidosis needs to be treated in the emergency department and is generally then followed by hospital admission. Category number 2 here is a more moderate level of metabolic acidosis. We see this in patients with renal insufficiency or overt renal failure. Treatment interventions can include administration of alkali, supportive medical care up to dialysis, and functional nutritional interventions to restore renal function. I've discussed that in my books now for about 10 years, and that information is also updated in the most recent version of Inflammation Mastery. Next, let's talk about mild metabolic acidosis. This is typically diet-induced metabolic acidosis and is extremely common, characterized by a urine pH of approximately 6.5, and the treatment here is diet modification and as-needed administration of citrate and bicarbonate. I think that we could also look at a 4th category of metabolic acidosis relative to excretory needs in patients who have been acutely poisoned. This was discussed in a landmark publication by Proudfoot and co-authors published in Journal of Toxicology and Clinical Toxicology in 2004. I'll talk more about that position paper during this presentation, but the clinical context here is acute poisoning, typically in a hospital setting. The specifically recommended treatment for alkalinization in this setting is intravenous sodium bicarbonate. But I'd also like to state here that a reasonable argument can be made that we're all poisoned with various chemicals and pesticides, and that therefore urinary alkalinization probably has therapeutic and preventive medicine benefits for just about the entire population. Also, a 5th category here, we could say relative functional